Hello YouTube, this is electrostatic revision. So I'll just pick up interesting problems, and here's the first one is about electrostatic force to gravity force ratio. Alright, so we start from the basics, and this is electrostatic is the part of electrodynamics because electrodynamics is more general case. Okay, so that's why we'll start from easier problems. However, this problem is not like quite easy, so it is sort of like easy medium level, maybe medium level, depending on the program. So welcome to general physics, and let's get started. Alright, so read carefully the statement of the problem. I just give some comments, grab your notes, grab your pens, and let's get started. So my comments is about this problem. Calculate the ratio of the electrostatic to gravitational forces of the interaction between two particles. In case of particles are electrons, that's case 1, and B part is particles of protons. Okay, that's the first part that we need to answer that questions. And actually the speech is about you need to find the ratio of the coulomb force to gravitational force. Because of the particles interaction, so we can say that electrons, both electrons and protons, they're quite small particles. Okay, so that's why Coulomb force and Coulomb formula related to how express force through the charges and the distance between them is valid. All right, it's not extended charge body. All right, so that's why you can apply basic formula. All right, so let's do that. So question A is about particles or electrons. So that's why in this case I will use the charge of the electron, which is E, and it's about 1.6 times 10 to the negative 19 coulombs, right? It's quite small. Okay, so that's our constant. Also, we can use the mass. In our case, is going to be 9.11 times 10 to the negative 31 kgs, right? So that's constant that you need to know. Also, if you write the equation, but before writing the equation, let's just have a look at the general picture. So let's say they're separated by the distance r, okay? And let's say two particles. So particle 1, so P1 and P2, two particles interacting. Okay, so obviously there is the gravity force. So gravity force, and here is that same gravity force but with negative sign. I use them as the vectors. And also we need to put, let's say they're both electrons in the first case, or protons. Anyway, they will be repelling from each other, so that's why that's going to be a force of that make them going apart from each other, right? So that's why the force of repelling, okay? While gravity force is the force of attraction always. So here is the both negative, so the same signs, the same charges with the same charges, yes, and with the same signs, they always repel, okay? So that's we're gonna put Coulomb force or electrostatic force if you like, and we're gonna put them in this way. And in case of the static or the balance, okay, in case of the balance there will be balance, but we're not specifying the distance, so that's why we don't know are they in balance or they have the resultant force, so each particle has the resultant force. We don't care about this, so we need to find just the ratio. So that's why we put the formula for each force. So Coulomb force, the absolute value of this is E squared for interaction of two electrons over 4 pi epsilon 0 and times the square of the distance between them, all right? So if you like, you can write using k, where k is the constant. So actually 4 pi epsilon 0, we assume that interaction occurs in the vacuum, so that's why we just do that. And in case of some dielectric, if this occurs in dielectric, so you need to put also epsilon, okay, dielectric permittivity of the medium. But we don't care right now, we don't know the medium, so that's why interaction occurs in a vacuum, we assume that. And also we need to put the force of the gravity. So gravity force is some constant gamma or a big G, capital G, and times the product of the mass. So it's going to be mass of the electron squared, this one, okay, over r squared. And now we need to find the ratio, okay, for electrons, coulomb force to gravity force is going to be equal to, let's see. So r will be cancelled and we'll stay with e squared over, so k times e squared and over gamma mass squared. That's what we have at least so far. Alright, so what we're gonna do, we need to plug the values. If you plug these values by row, just plug the charge, plug the k. So by the way, you also need to get to the reference and find k and gamma values, okay? So use them. And if you calculate this ratio, we'll get order of the power around 10 to the power 42. Can you imagine? So electrostatic force is much greater than the gravity force. So it's really much more greater, okay? But more precise value is 4 times 10 to the power 42. All right, so if we do that for protons, we'll get the ratio. Hold on, just let's estimate. So what do you think about protons? The charge is the same, but if we take a different mass, so mass of protons is more, obviously we will add more gain to the denominator. So we'll increase denominator. That means the ratio should be decreased. And indeed, if we plug the mass, okay, which is 1.6 times negative 27, right, kgs. So, okay, you'll decrease by about 6, and the power and the order is going to be 10 to the power 36, okay, and the factor is here in scientific form is going to be 1. So that's for protons interaction, protons. All right, that's for electrons. Hence we got those ratios, so you can use that and just lay out, put in frame as the final answers here. So pretty much easier, right? And let's try to go to the second part. All right, so switch the marker, and right now the second part asks us about what is the specific charge Q to M for each particle which are identical to each other in terms of their masses and charges. So basically we take in two identical particles with charge Q and mass M, and they interact in the same way, okay? Q and M, they're identical, so means they're the force of repelling force basically stays for coulomb force or electrostatic force, okay? That's why they will be repelling. And what is hold them is gravity force, okay? Gravity force, yeah, gravity. So in this case, you need to figure out the specific charge for each particle. So you need to find Q over M ratio, okay? What's called specific charge, okay? So basically that's the question sign. Sorry, one more time, okay? If those particles are in equilibrium and hence at rest, okay, when interacting with each other, obviously they should have, according to the picture, due to the fact that they're in balance for each particle, the resultant force should be 0, right? Otherwise they will go and have acceleration, okay? So that's why we need to figure out this ratio. Of course, we use the same balance method, second Newton's law, for each particle. And what can we figure out? So k times e squared over the distance r squared is going to be equal to the same gamma mass squared over distance squared. All right, from here we can figure out e to m ratio, okay? In our case, I'm not sure about E, so that's why it's better to use Q, so general charge, because we don't know which particles interact. Okay, so that's why instead of E, let's consider Q, some general charge. And from here, we define the ratio Q to M as simply so R squared will be cancelled, and we'll get gamma over K, which in other words allows us to write as 4 pi epsilon 0 gamma. In case of the medium, you just need to add electric permittivity of this medium, right? So epsilon for the medium. Right now we considering vacuum for the medium. Okay, so if we calculate that, if we plug all the constants, we'll get around 0.86 times 10 to the negative 10. So it's going to be coulombs per kgs per kilograms. So that's going to be the ratio. Alright, so hope you got the same because it's pretty much easier problems. So it takes into account understanding of basic formula for each type of the force. Yes, we have gravity interaction, we have electrostatic interaction in this case, using a Coulomb force. Okay, make sure you remember that. And don't forget to look into the reference in order to define constants. So it was easy. And so next time we'll just pick up something special, maybe harder. Take into account not just small particles, but atoms. Why not? See you next time.